I'm Kenneth Shade, your math instructor. I just wanted to go over the final review with you real quick. There's 50 questions on the final review. There'll be about 34 questions on the final exam. Remember, you do get a 3x5 note card and also a basic or scientific calculator you can take with you to the exam. So what I'm going to do is go over each one of these type problems. If you have a problem with one of the ones I did on the video, please email me back and let me know which problem that you struggled with. I'm going to try to go step by step and explain exactly what to do. So on number 1, it says solve using the addition and multiplication principles together. So basically what you're going to start with here is you're going to start with the distributive property. You're going to take that 2 and distribute it to both of those inside the parentheses. So we get 2 times 5x is 10x. And then 2 times a negative 4 is a negative 8, or you can put minus 8 instead, equal to 12. Then we're going to add 8 to both sides. We're going to take 10x equal to 20. The negative 8 and the positive 8 zero out. Divide by 10, and x equals 2. And that's your final answer. We won't go any farther than that. Go to number 2. List all numbers for which the rational expression is undefined. Well, when is it undefined? It's undefined when the denominator, a minus 4, equals 0. Because when this is 3 divided by 0, it's undefined. You can put that in your calculator and hit 3 divided by 0, and you're going to get error. Quote, some calculators say divide by 0 error. Because you can't divide by 0, it's undefined at that point. So the only thing we got to worry about is what's in the denominator, a minus 4. When is a minus 4 going to equal 0? Well, if I add 4 to both sides and solve for a equals 4. So when a equals 4, that makes this undefined, which would make that rational expression undefined. When a equals 4. Number 3, it says simplify if possible. Now anytime you have x minus 5 over 5 minus x, or any of those, any numbers where all the signs are different. This is a positive x, this is a negative 5. This is a positive 5, this is a negative x. Those are just the opposites of each other. So when you divide this out, you actually get a negative 1. Because your x's are negatives, your 5's are negatives, so when you simplify it ends up being a negative 1. So we can simplify that down. Solve for a equals 1/2 base times height. Now a lot of people struggle with this because they're like, oh, it's got a lot of letters in it. You're still going to use the same principle as you would if there were numbers. Now the first thing I would do on this particular problem is get rid of the fraction. To get rid of a fraction, you multiply by the reciprocal. So 1/2, the reciprocal of 1/2 is 2 over 1, or just 2. So if I multiply both sides by 2, I get 2a equals, and the 2 simplify to 1. So we get 1 times b times h, so I got b times h on this side. Now it says to solve for h. So we're trying to get h by itself. So I don't want to move h, I just want to leave h alone. So what do I need to get rid of? I need to get rid of the b. Well, it's b what? Times h. How do I get rid of multiplication? To get rid of multiplication, I do the opposite, which is division. So I'm going to divide by b. So my final answer is going to be 2a over b equals h, because b over b is 1. So don't make the variables really difficult. Just do it as if they were numbers. If I had 4h, what would I do to solve that? I'd divide by 4. No difference than if I had bh, or b times h. I still divide by that term. Solve using the addition and multiplication principles. So basically they want us to take this negative 13a minus 10 greater than or equal to negative 12a minus 21. Now inequalities we don't have to worry about. They're the same as equations. The only thing we have to worry about is when we get to the very end, if we don't do this a certain way, we're going to have to look at it. Now what I like to do is I like to put my a's together first. So what I would do is I add 13a. to both sides. And some of you might say, well, what if I added 12a? That's fine. I'll talk about that here in a minute of why I moved the 13 instead of the 12. So when I add 13a, those simplify to 0, 0 out. Get negative 10 greater than or equal to negative 12a plus 13a is 1a. Bring down to negative 21. Now, do you have to put the 1? No. 1a and a are the same, so if we don't want to put the 1 in there, we don't have to. Then I'm going to add 21 to both sides, because I'm trying to get a by itself. So now I have a, and I'm going to get rid of the 1 now, because 1 times a is a. 21, 0 out, greater than or equal to. And then negative 10 plus 21 is 11. Now, problem with this is the variable's not on the left, so it's on the right. When you're reading an inequality, you always have to read from the variable. So in all reality, this is really a is less than or equal to 11. Doesn't matter which way you write it. If you're on the test and you leave it like that, that's fine. It's not going to bother me. That's the correct answer. So is that. You have to read it from the variable. This is not 11 greater than or equal to a. It's a less than or equal to 11. Always read from the variable, whether you have to go right to left or left to right. Now, before I told you that there's a little difference between an equation and an inequality. What that difference is if you have a negative number, and I want to show you real quick one of the reasons why I didn't add the 12. Let's do it real quick. Add 12a to both sides. If I add 12a, what happens is I get a negative 1a minus 10 greater than or equal to negative 21. Then I add the 10 just like I did before. The only difference is I have a negative 1a instead of a positive 1a. And here's where the difference comes in. When I divide by a negative 1 to get rid of that 1, because I can't just do like I did a while ago and have just 1a, it's a negative. So I got to divide by a negative. Well, when I do that, a red flag should pop up in your head. When I divide by a negative or multiply by a negative on inequality, what happens is, one simplify out, this inequality switches from greater than or equal to less than or equal to. That's why I try not to get a negative on one of the sides with that inequality on there, because if I have to multiply or divide by a negative, I got to remember this rule of switching the inequality sign. I'm going to cut this video up into pieces so that way it doesn't take up as much space. So hopefully this is the first 5 problems, and I'll try to do I'll do some more here in just a little bit. Let's go to the next video.